next is the comparator lah. So the basic function of comparator is to compare the material of two binary. Okay, for example, we have the A and B. So, okay, A and B. So at actually the comparator we have three outputs. For example, A equals to B, or A greater than B, or A less than B. Okay, this is some example of the output for the comparator lah. Okay, so this is they use the OR gate to compare between two binary number lah. For example, they compare with this one, A0 and B0, A1 and B1 lah. Okay, but this one is, for example, like A equals than B, or A not equal than B. Alright, for example, like this exercise, you can see this one, A 10, B is 10. So you know this A and B is the same lah. So that's why the output will be equals. Okay, the output will be equals. For the B slash B, A is the 11, B is the 10. That means the output will be not equal lah. Okay, not equals. Okay, that I mentioned to you, the comparator we have three outputs actually. So we have A equal than B, we have the A greater than B, or we have A less than B lah. Okay, so you can see this one, the IC lah, the logic symbol for the 4-bit comparator. Okay, for example, this is inputs A, this one input B, and then this is output lah. So that I mentioned to you, we have three outputs. Okay, so for example, this one A greater than B, A equal than B, A less than B. Alright, for example, like the first we have A0 0 0 0 0, for example, and then B0 until B3 we also 0 0 0 0 0, and then we know the answer will be A equal than B. So this one will be active lah. Okay, because of this one will be same, so automatically the output will be here. So if output here, so automatically here will be 1. Okay, will be 1, the rest will be 0. Okay, this one will be active lah. Active will be 1, and then this one will be not active. This one will be low lah, so will be 0. Okay, so this is some example. You can see this one, some example. So we have 0 1 1 0. Okay, for the input A, and then for the input B 1 1 0 0. Okay, for the input B. So we know this one will be 6, and this one will be 3. That means A greater than B. Okay, A greater than B. So the output will be high here. Okay, 1 here lah, and then the rest will be 0. Okay, you can see this one, So this is the function of the comparator lah. Okay, so this some example. You can see some example of IC for the 4-bit comparator lah. Okay, this is symbol. You can see this is symbol for comparator, and then this actually the real IC lah, the real IC. Okay, you can see this one is the point. This mean the IC will be start here. Okay, the leg one will be start here until this VCC lah. This is power supply, and then this is ground. Okay, actually this is some example of IC for the comparator lah. Okay, if we want to compare for example more than 4. For example, this one 8 bits number lah. We want to compare 8 bits, so that means we have to use 4 bit lah, 2 comparator. Okay, we have to cast interconnection between 2 lah. Okay, so this one will be 1 for comparator, and then this one another one for comparator lah. So this some example of circuit lah. Okay, this one okay, this one for the first comparator, and then second will be this one, the second comparator lah, and then this is output. Okay, this is how to connect connect between 4 bit to 8 bit. Okay, for example, if you want to compare more than for example like 16, so that means we have 4 another 2 comparator. Okay, so this is connection lah, and then this for example this one will be this one will be positive. Okay, to power up the comparator, so we give the 5 volt here, and then the rest will be grounded . Okay, this one will be use the custom comparator lah. This one custom comparator using the logic gate. Also we can use the logic gates to do the comparator. Okay, to do comparator. Either you can use the logic gate or you can use the IC. Okay, up to you lah. This some example you can use the logic gate to do the comparator function. Comparator function. So for example like this, we have some example here. For example, so you got, okay. For example, the output will be height. Okay, the output will be height when A greater than B. Okay, that means the output will be 1 when A greater than B. Okay, here we have 4 lah. We have 4 inputs and the outputs. We have 4. Okay, this step we have to draw the truth table lah. Okay, the truth table. Okay, this is the truth table of 4 inputs. Okay, for input A1, A0, B1 and B2, and then this output. As the the example, the A greater than B. Okay, A greater than B. This one A and B will be same. That's why the output will be 0. Okay, this one B greater than A. So that's why 0. Okay, you can see this one because A greater than B. Okay, that's why the output will be 1. Alright, for example this one. Okay, this one will be same. A and B will be same. That's why output will be 0. Okay, this one. Okay, this one A less than B greater than ni lah. B greater than A, so the output will be 0. You can see this one for input here one but that means A greater than B, so that's why the output will be 1. Okay, from this one. Okay, we got this truth table. We can use the K-map lah. Okay, we can use the K-map. Okay, and then we can get the simplified Boolean expression. Actually you can use this one. Okay, this is standard original. Okay, from this truth table. Okay, for example this one from this one. Okay, we have 1 2 3 4 5 6. That's why we have 1 2 3 4 5 6, and then we can use the rules, okay, to simplify until we get this one. For simplicity, normally we can use the K-map lah. Easy for you, because I mentioned to you, if you want to use the K-map, make sure this Boolean expression must be on the SOP lah. Okay, SOP form. Okay, standard SOP form. Then you can use the K-map lah, and then you can get the simplified Boolean expression. Okay, and then you can get this. After that, you can draw the logic gate lah. Okay, logic gate based on this output. Okay, this one this is the comparator lah. The comparator using the logic circuit lah. That's why another technique we can use the logic gate to do the comparator lah. Either we can straightforward using the IC. Alright. Next.